Hello, this is Jack Gassett with Gadget Factory, and today we're going to do an overview of the Sump Logic Analyzer VHDL code. So to start out, this is the view that you first see when you open up the project in Xilinx Webpack, and the top level module is logic_sniffer, and this is the main module that controls everything. And the first important thing to look at is these are some generics that have been set up that allow basic parameters to be passed in from the command line. So if you're synthesizing the code, basically this is how we synthesize multiple bit streams from one common code base. And the first parameter is memory depth, and that's the most important one. And that actually controls whether you're generating a bit stream that has 24K memory depth, or 16, or 4, or 6. The other important one is the COM type. You can select whether you're going to synthesize with UART communications or SPI communications. Okay, so on the left, we can actually take a look at the hierarchy and see how things are related and connected. So it's a little bit confusing because the design is it's parameterized, and basically all the options that could be synthesized show up on the left, but in reality you'll only synthesize one option at a time. So you see multiple Clockman modules, but only one will actually ever be synthesized. You also see multiple SRAM_BRAM modules, but once again, depending on what you select with those generics in the beginning, only one will actually be active. And another example of that is you see both the SPI and the UART or EIA232 modules show up, but only one is going to be implemented at a time. So moving on, the meat and potatoes of the project is the core, and this is the logic analyzer core that provides all the functionality, such as sampling, triggering. The RLE lives here. This is flags for selecting how sampling is going to happen, and how you set up your triggers and that sort of thing. The other kind of key modules are the UART and the SPI modules, and only one at a time can be selected once again. And then the other big portion or big part is the SRAM module, and in our project for the OpenBench Logic Sniffer, this actually uses BRAM, which is internal to the Xilinx chip. Both the RAM and the communication modules live outside of the core, and that's a nice feature that the original developer Michael Poppets implemented, because it makes it really easy to change what kind of memory you're using, whether you're using SRAM memory, external SRAM memory, or internal BRAM memory, or if you want to use UART communications or implement SPI communications like we did for our project. The other really important piece is the actual constraint file, and the way you modify what the constraint file is, it actually defines how all the pins actually connect to the ports. So in the core, we actually have ports defined for the RX, TX pins for UART, and external triggering and that sort of thing. And I'm about to run out of time, so I'm going to wrap this up for part 2.